Hello everyone, welcome to my YouTube channel, Paul Mathematics Academy. Now in today's video, we'll be looking into a nice topic in mathematics. That's inverse Laplace transform. Now the question says, compute the inverse Laplace transform of the following. The first one, y is equal to 1 over 3 minus 5s. Second one, y is equal to 5s over x squared plus 9. Third one, y is equal to 2 over 3s raised to the power 4. The fourth one, y is equal to 3s plus 2 over x squared plus 25. Let's solutions. Now, let's get started solving the problems. Okay, now the first question, let us start with the first question. The first question. So we have y(x) equals 1 over 3 minus 5s. Now, the first thing I'm going to do here is to factorize 5 out in my denominator. So if I factorize 5 out in my denominator, so I'm going to have 1 over 5 into brackets 3 over 5 minus s. Look at something. If I multiply this by 5, you see 5 multiplied by 3 over 5, I'm going to get what? 3. The 5 multiplied by s, I'm going to have what? 5s. So that's what I'm going to have. I get it now. So now let's continue. So this is the same thing as 1 over 5 into bracket 1 over 3 over 5 minus s. Now let's find the inverse Laplace. Okay. So the inverse Laplace of 1 over 5 into bracket 1 over 3 over 5 minus s. So this will be equal to 1 over 5 multiplied by the inverse Laplace 1 over 3 over 5 minus s. Now let me quickly recall something. Now if you take the Laplace transform of e raised to the power of minus xt, now this is going to give you 1 over x minus c. Are you getting what I'm saying now? This, if you take the inverse Laplace of e raised to the power of minus xt, so this is going to give you, sorry, this is x, so this is going to give you 1 over s minus x. Now what can we do here to manipulate this to be in form of this? Now let's do the manipulation, right? So now I can rewrite this as, 1 over 3 over 5 minus s can be written as 1 over minus s plus 3 over 5. But I want this to be in this form so I can factorize minus out in my denominator. So if I do that, so I'm going to have 1 over minus into bracket s minus 3 over 5. Do you understand it now? So now our inverse Laplace transform now be, so this negative sign will come out here to make this 1 over 5. I'm going to have minus 1 over 5 inverse Laplace of 1 over s minus 3 over 5. So this is going to give me e raised to the power of, now what is my x here? So my x here is what? 3 over 5. Okay, so that would be e, don't forget it's minus 1 over 5. Minus 1 over 5 multiplied by e raised to the power of minus 3 over 5t. So that's the inverse Laplace of 1 over 3 minus 5s. So that's how you find the inverse Laplace of any function in this form. Okay, now let's move to the second one. We have yx equals 5s over s squared plus 9. Okay, now I want to find the inverse Laplace of this. So that will be inverse Laplace of 5s over s squared plus 9. So this is equal to, so let's bring this 5 out. That will be 5 inverse Laplace of s over s squared plus 3 squared. Don't forget 9 is also 3 squared. Okay, so I will quickly recall something for you guys now. Now don't forget that the inverse, the Laplace of cos at is going to give us x over s squared plus a squared. Now, can you see that this function is in this form now? You have s, you have s. Okay? You have s squared, you have s squared. You have a here, you have 3. So our a is now 3. Okay? So therefore, we have 5 inverse Laplace of s over s squared plus 3 squared is equal to 5 cos. Now, what is our a? That is 3. Cos a t. So that is the answer to the second question. I'm sure you are getting it. Now, the third question says you have ys is equal to 2 over 3s raised to the power of 4. Now, let us do some manipulations here. Okay? Now, let's do the manipulation. Now, I can rewrite this function as 3 factorial over 9 multiplied by s raised to the power of 4. Now don't forget that 3 factorial is equal to what? 3 times 2 times 1, which is equal to 6. Okay, and then 6 over 9, so that will be what? 2 over 3. Okay, so I can write this as this. So the next step I'm going to take is that let's factorize this 1 over 9 out. I'm going to have 1 over 9 into bracket 3 factorial over x raised to the power of what? 3 plus 1. 3 plus 1 is 4. Okay, so 3 factorial over x raised to the power of 3 plus 1, and it's the same thing as this, same thing as this. Okay, now let me quickly recall something. The Laplace transform of t raised to the power of n. This is going to give you n factorial over Sn plus 1. Now, can you see that this is in form of this? Okay, so then taking the inverse Laplace now, the inverse Laplace of 3 factorial over s raised to the power of 3 plus 1. So your n here is what? 3. Okay, so you are going to have 1 over n t raised to the power of 3 as the inverse Laplace of this function. I'm sure you understand what I'm doing now. Now, the last question for today is we have yx is equal to 3x plus 2 over s squared plus 25. So applying linearity here, so if you're applying linearity, so this is equal to 3s over s squared plus 25 plus 2 over s squared plus 25. Okay, so now let's take the inverse Laplace of the two functions here. So you're going to have the inverse Laplace of 3s over s squared plus 25 plus the inverse Laplace of 2 over s squared plus 25. You understand now? Okay. We can bring out this constant here. This 3, we can bring it out. Okay? So if I bring this 3 out, So let's check what's going to happen there. Alright. So this is going to give us, oh sorry, can you see it now? Alright, you can see it like this. So this is going to give us ys equals 3 inverse Laplace of s over s squared plus, now this is 25. So I can write 25 as 5 squared. So 5 squared plus, so this is 2 here. Okay. So let me bring out the 2. Does it matter? No, it doesn't matter. I bring out this 2 here. Yeah, because I want to do a manipulation here. Okay? So this is just what I'm going to do. So this is the same thing as inverse Laplace of this is 5. So let me just write 5 out here, multiply by 2 over 5 over s squared plus 25. Now, do you see the manipulation I did here? This 5 can cancel this 5 and you have your 2 again. Okay? So now, this is what I'm going to do now. I'm going to bring this 2 over 5 out here. So mathematics is very interesting if you can manipulate very well. Very interesting. So then you have y s is equal to, now if you look at this one, is in form of this. That is, we have a general formula for that here. So this is going to give us 3 cos. So what is your a here? That's 5 cos 5t plus, now for this I'll bring out this 2 over 5. I'm going to have 2 over 5 multiplied by the inverse of 5 over s squared plus 25. So let me quickly recall another formula here. So that we use to evaluate this. So let me write the formula here because of space. Okay, so let me write it here. Now you recall that the Laplace of sine at is going to give us a over a squared plus s squared. Okay, so that's what I'm going to use here. So we can now see, so we can now see that this here, can you see it? Okay, this here is in form of this. So your a is 5, that is 25, that will be 5 squared. So let me just put 5 squared here as for 25. So your a is now 5. So this is going to give us, this particular one is going to give us, that will be 2 over 5 sine 5t. Do you understand that? So hence y has, so sorry, okay, so that you can see it very well, ys is equal to 3 cos 5t plus 2 over 5 sine 5t. So that is the inverse Laplace of the function. So please don't forget to subscribe to my channel, like my videos, share my videos to your friends, also like mathematics. Thanks for watching, and click the notification button, because so that anytime I upload video you'll be the first to watch it. I love you all. Thank you.